Good afternoon. Only just. I want to thank you for coming and welcome to this meeting. I will note that this is a meeting that is happening at the IETF, but of course it's not strictly speaking a part of the IETF meeting, which is why there's no note well up there and there will be no blue sheets. I'm Andrew Sullivan. It's my very great honor to welcome and introduce to you Professor Jun Murai, who is a board member of the WIDE group, who are our hosts here at the IETF in Yokohama. Professor Murai is well known here in Japan and justly famous as the father of the internet in Japan. His accomplishments in networking reach back to the 1980s. He, as I just mentioned, founded the WIDE project, and he has been honored by the Internet Society and the IEEE. He has countless honors to his name, and today he's going to talk to us about some very interesting things. So rather than listening to me blather on incompetently, I'm going to welcome Professor Murai. Thank you.
Okay, yeah, thank you very much for the introduction. And this is Jun Murai from WIDE project founder in the Keio University professor. So the title is a little bit strange because probably 5 days ago, then the IETF needs a title of my talk, and then I asked them that what kind of a talk you want, and then something internet, something Japan. So I named this way, but never mind about the title. Today, what I'm going to do is basically sharing with what happened around me with you, and I've been a long participant on IETF, therefore that's what I really want to do. So this year is 2015. You are in Japan now, and so let's start from my thought from here. 2015 means a lot to Japan, and then it's a lot of new activities going on, and I'm going to introduce you later, but let me share my private information. Okay, this is my car license plate, and all my vehicle license plate, I always using those 4 digits. 1984, that's when, 31 years ago, by the way, that's when we started the computer network in this country. Okay, so that's 1984, 31 years ago. So this is the 30th anniversary of this one, privatization of the telephone company. And therefore, before this year, 1985, it was illegal to connect computer to the telephone. Okay, what is this? Illegal. Okay. So the challenges on the computer network in this country happen very similar to elsewhere in the world. Challenging to the existing infrastructure, communication infrastructure, challenging for the digital communication, like many other countries. Then the entity privatized, but the reality is almost nothing happened since then, because it's very much a bureaucracy, government regulation. They didn't understand about the internet, and so repeatedly I was asking to the government and the regulatory authority that this is the internet, and then do you think it's okay? And their answer was always, oh, I think it's okay. And then I asked, can you write it down that we can create the internet, we can operate the internet? And they said, no, I can't write anything. But you said yes. I think it's okay. But So that was a conversation probably happening everywhere in the world, but they didn't know how to handle the internet as a society. Okay, so I like to share the real issues of Japan, and then because the real issue has to be solved by the internet and its services now today. So that's in a way, in an indirect way, or in a more toward abstract way, internet has to solve the issue. Therefore, I like to share the issues of Japan. And then IoT, that's a buzzword, super buzzword, probably super buzzword from point of view of comparing with any other country in the world. Japan's buzzword level is very high. Okay, all the government wants to fund the IoT. So if you need money, come to Japan and then shout IoT, then you can get it. Okay, so that's the IoT issues. And also, I like to share with all the experts of the internet in this room, and then beyond. There is on the internet, somebody is listening to my talk. Therefore, I need to share about NREN. Maybe you're not familiar with the word, National Research and Education Network. General term, I'm going to do the announcement today about our new activities, but relating to that, then I need to discuss about the NREM with you. So those are the three subjects I'd like to share today. Okay, so what is the real issue? This is a long-term goal, IETF. This time is 94? 94. So it's like a 19. Yeah, I think so. Because I missed that thing. So in a plenary, Ras, IETF chair, showed this slide to you, if you remember this, because most of us couldn't participate on this time of the IETF because of the earthquake. Right after that, and then I said, thanks to the internet, because the internet helped right after the disaster. So we were survived, many of us, and then all the help from the community around the world, and especially from the internet community, helped us. And then the packet switching network of the, internet was battery backup, by the way. The smartphone everywhere, GPS on 100% of the devices, phone devices in that country that time. And therefore, the location was there. Telephone line shut down, control, and then we can't make any voice call, but the packet was there. And as I said, all the ground station as a mandatory and regulated as 3 hours of a battery backup. Therefore, 3 hours it worked. And you were charging your phone, everybody, even for the lazy boys, they charged smartphone every night, okay? So then they are connected. And so they used the post-disaster activities. They were on the internet. Therefore, I sent this message to you while we were working very hard on recovering the internet on a disaster area, because that was, we learned that the recovering the internet is the best way, one of the best way to recover anything. To support the medical care, support the, the delivery, the items to the disaster area, anything started from the internet communication. Therefore, we thought that we were very important. So that's a very, very striking understanding how important the internet infrastructure is to support the disaster and the other thing. So issues in Japan, the primary one is about the earthquake, and all the the earthquake is now along with the plate, and Japan is right on top of it. Oh, by the way, the red means all the earthquake record depend on the size of the earthquake and plotted on the map. That's a map you are seeing. So yeah, look for the safe place carefully for your retired residents, right? Okay, this is nice place to live. This is a nice place to live. But the Japan is living with earthquake, right? And there also this area, earthquake and the natural disasters, like weather, warming, global warming is suffering even for the Japan, Tokyo. Many people died by heat these days. And we have to be very careful about, by the way, the Tokyo Olympic, which is starting on August. And on the particular day of opening of the 2020 Olympic, that day, this year, 3 people died in Tokyo because of the heat. Okay, so be careful, and we have to do something. The internet, can internet do something for that issue? So those are the issues of the world and Japan. But this is a pretty much cyclic thing for the several 10 years. Seems like a beginning of it. So that's what we are expecting. So other thing is Japan, 1950, a little bit before I was born. This is age. This is population, male, female. 1950, 2000, 2020, 2050. Okay, we recorded. Keio University just started the Centenarian Research Center, which is just doing researches on people over 100 years old. And we started to plan this research center several years ago when the population of the centenarian people in this country was 30,000. And the announcement last month from the government was 60,000 now. 60,000 people who are more than 100 years. So the heavyweight for the economy, for these people, it's going to be like 2 times, 3 times more of the economy is going to be depend on this sizable people. So this is the elderly society is another big issue. So I just show the 2 very serious examples. But think about those issues. Then what technology in the internet can do for those issues? Yes, we can do. So many things. Like the internet saved us when the earthquake attacking us, then the internet saved us in many ways. The same way, we can utilize the internet infrastructure, internet services on the internet will solve the issue. The problem in this community, probably common with this community. This is the internet. They don't care about this one. Okay, we have L1, L2, TCP/IP, web, API. They don't know this is existing. We are working for this, okay? So the application data services, that's what they know. They utilize this and they're solving the issues, but they can do that only if we exist, right? So the internet is on everybody, for everybody participating on the internet. So the bidirectional communication from the people and the individual. And then they would be very creative, because a human being, by definition, it's a creative and innovative thing. They are the users of the internet. It's not the users, I said the participants. And IoT devices, sensors, low-cost commodity. They are connecting to the internet, speaking TCP/IP directly these days. Used to be there's just sensor proprietary communication or whatever, but now this is a tiny full computer with a CPU memory and the networking devices. They can now talking the full TCP/IP protocol stack, and then generating unlimited amount of data on the internet. And then utilizing those data, and then creating the new services, and then the new applications. That's what we've been doing. And for the CPU allocation, then we do have a CPU everywhere. Then we don't really have a way to utilize them in a sophisticated distributed processing manner. But many of the approaches on operating system, browser, technology area to utilize those CPUs for the parallel processing thing and distributing the processing purpose is to analyze those huge growing data with a local manner or the globally distributed manner. So that's a lot of artificial intelligence area for the automatic driving system, vehicle, robot, and those areas have been working on. So any services on the internet can be achieved. Okay, so I remember how the computer is going to solve the issue of the real issue things. Then I remember in the 80s, I visited Stanford University, and then the philosophy department did put all the text into the computers and analyzing them. That's a new way of understanding people, understanding human through the philosophy study. And then they utilize the computer. I was kind of surprised and impressed at the utilization of the data for the analyzing the human being. And then ELIZA and the first wave of artificial intelligence started with text, automatic translation, text analyzing, language analysis. Those areas started to work later, and the network came. And so please appreciate all the detailed use of the computers on the background. So I picked the right one historically, by the way. Anyway, so when the web started, and then the internet connected all the web, and then the web analysis, like search engine and the other thing, is the text, still the text. I mean, so the searching cat, and then there is a cat result in here. Other text and the languages, but then eventually that turned out to be the images. So image analysis and the language analysis are a little bit different from a big data analysis type of approaches. So getting back to Japan. Japan had a serious worry about the language. When we started the internet, connected, and coming to IETF, nobody's speaking our language. We all speak in English. And then that was very, very, the hard things for some of the Japanese people when we started to be in the IETF community. So then the RFC 822 defining the email explicitly said that the email text has to be ASCII English. and so email has to be in English that time. And then we introduce we struggling on what type of a message on the internet. The working on a Unix internationalization very much, and also the multiple text into the email and the web eventually. So one of the history of a Japanese internet, especially in the early stages, it's a multiple language accommodation on the internet, which has been, I believe, very successful now. And then passing to the web architecture and the CSS. Just recently, the HTML5 CSS was approved with the vertical writing concept and in it. And it's been a long discussion, but I'm very glad to see that the accommodation of the multiple languages was accepted on the W3C community for the standardization of the web. But it's always a language. We've been working on it. We still using the Japanese languages, and we still respect the diversity of the languages on the global internet space. And if that is the case, then the change from language text to the images and data, what that means, and then so that's one of the reasons that now the contribution from all over the world are independent from the languages, and then it's more to the mathematical probably talent that we're going to need. But anyway, so the data, including the text, though, working on the internet, that's the time we are facing today. And therefore, it's a kind of, in a way, encouraging the country like Japan to work. So the WIDE project started as a, of course, the working on a network, working on a distributed processing thing, and the operating system. Well, one of the very important experiments WIDE project did was the transportation area. So we wanted to visualize the first drop of rain, and which was achieved on the front glass of the automobile. So drivers gonna start moving to wipe the first, rain. And then the idea was to collecting those initial motion of the wiper with the location information binded and collected with a massive way from automobile. So that's what we did. So we call it the internet car. And then we did the presentation at IETF many times, starting from the mid-90s. But then it's a location, and finally we were granted for the more than 1,000 taxi cabs testing in Nagoya City as a WIDE project, working with all the regulatory bodies. This was the start, excuse me, of so-called the probe car system. All the sensors from the automobile collected on the internet with the location information, and then on the analysis, and then it's we wanted to be the data format and to be standardized and other things. So we made a lot of efforts, and one of the presentation I made in a Europe RIPE meeting, and then I talked about this, and then we had a tremendous success on the experiments, and then so somebody helped me because during the experiments, then it's Nagoya City was stacked with snow. For it's never snowed for 20 years or 40 years, but that particular day, in the middle of the testing, then they snow. And then all the ABS, anti-locking braking system is going to collected, and then it was amazingly, giving us a success from a detection of the slippery street collected from the autonomous cars, and which was a kind of symbol of a success. And so we were lucky from that point. But anyway, so getting back to the right presentation, then it was well accepted, and then it's amazing things, and then they all liked it. And then I said, any question? And somebody raised a hand, and he said, simply, I don't want my car location to be known by my wife. Then, okay, usually we don't think that way. We are engineers, so we were young, by the way, that time. And so that was the beginning of a privacy in the security things into this data. And then we've been working on that area as well. So we didn't know. So I showed my license plate openly here, but then many people, we understood that time that many people hate that. So we had to do something. So we've been continuing the work with various ways to protect the privacy when we are collecting the data over the internet from the various sensors. And then the probe car was been very much success of wide projects since then. The very much appreciated the use of the probe car was probe car tend to be after that the close to the individual vendors that after that. The Honda got the Honda customers information, Toyota got the Toyota customers information, Nissan got the Nissan information. So our original intention was that the kind of creating the open platform, but because of the privacy, then it was very difficult. Okay, so anything vertical, putting the horizontal platform is not that easy. So I've been discussing with the automobile vendors in Japan for many times, but then as soon as the smell of the money, data smelling money, and they would like to close the data. So that was but before, what we did was before smell of the money, then we standardized the data format. Okay, so the data format was standardized before they closed the data. And when the earthquake again happened, 2011, then one of the Honda engineer put that on the web, and then showing the real-time mapping of the Honda automobile, how they moved. Then what people wanted was that is this street safe for the vehicle to pass a bridge? That kind of information was not available, but collecting from each individual automobile, then the Honda website started to show to everybody that, okay, then everybody noticed that, okay, we want to deliver this food to that suffered area, but this bridge is broken, but this bridge seems to be okay. And then that happened, and then helping each other for the information. But as soon as the Honda information was very well accepted and being used to save people's life, then other companies follow, and therefore concatenated, because it was standardized long time ago. So they could be merged. So, okay, so this is very difficult thing. It's happening all the time in all the industries, but we think this is a very important role for the engineer to work and standardize the data format and the interoperability thing, which is really important things for the things like that. And we understand that still somebody I don't call the name, was smelling the money and providing all the 100% internet car, connected car. What's the Japanese name? なんだっけ? No, that's well, network car, connected car in Japanese, maybe. Anyway, so so that was 2 weeks ago, press announcement. So it's still going on, but still we need to work that all the data they have, probably that can be creatively being a platform for the social purpose. Wait a minute. Okay, this is another subject that I recently been involved. The 3D printer. So one of my university's brain science professor told our students that before the first class, and then you scan your brain and print it and bring it to the class. And so all the students like this, putting their own brain printed in front of each of the students. So they are looking at each other. Oh, your brain is smaller than mine. But this is, sorry about the color, that was the filament we all have. But anyway, so this is a brand new way of learning about how brain works. And then it's a personal, very much personal product, and then it can be easily done. This can be a standalone, you can do that. But many of them, the printer is now connected to the internet, and then with the social network and the other things. So if you look at this button, download this thing, you push a button, and you get this very nice one immediately, right? Okay, so now it's on a social network. This instruction on YouTube, and this platform is everywhere, and push a button, and you can get the thing, not the music, not the digital data, but the thing. Okay, so that's a digital fabricator thing. So one of the students created this, and then immediately, this is a very effective way of writing things, because the 3 lines at the time. But then this was immediately distributed all around the world, and the cheating pencil. But since this data is like a programming language, data, so it can be modified 3 to 5 to create a music, support the music people. See, the 3-dimensional data being standardized openly in a many way of this type of a format now. So now the things can be distributed and shared on the internet now. Okay, so with modifying color, modifying the texture and everything. So when I was discussing one time with Yamaha CEO, that Nakata-san, that if your music instruments design, it's going to be like this format, and shared on the internet, then everybody can print the Yamaha music instruments and play the music. So it's great. And he said, no, not great, because people don't buy Yamaha music instruments anymore. And I said, no, if everybody playing the music instrument, they would buy Yamaha instruments more than today. And he was convinced. But unfortunately, before convinced, we drank 6 bottles of sake. So he might not remember. But the point is scanning the music instrument and then producing the music instrument. That's all digital data on top of the internet. If this happens in the world, then no delivery. So delivery people, your job is done. Okay? So no tax, no customs, because it's free internet exchange of digital data. So a lot of impact on a social way, especially on the medical area. We worked very hard that because the soft materials and other things can be printed. This is an example. Let me see. I wonder if I can show this type of a thing, but this is a water liquid in it, and then the soft materials, so that it can control with any kind of purposes, even inside the body, and any other purposes for the things. So that's what we've been working on. So another thing except for the medical thing, is that, we've been working on RFID things to putting the unique ID to the product. So one of the questions is that when the 3D printer is printing all the things around the world, copying everything, then how can we control the product liability, copyright, and the intellectual property, and the quality control type of a thing? So the answer might be, we don't know, but we decided to put every single 3D printer to be equipped with the RFID installer in it. Oops. So when you see carefully, when it's designed to put the RFID, then put the RFID and then make it as a product, so that you can identify the object and uniquely, even if you are reproducing the many of the same design. So that if you bring that thing with a unique ID for the kind of testing lab or whatever, then to guarantee that that is yours or whatever, the purpose, intellectual property, whatever the purpose is then it can be done. So, so we call it the QIP, quality control, intellectual property, product liability for the digital fabricator thing. So leaving the digital fabrication thing, let me talk a little bit about the TV, because this is one of the characteristics of this country. Okay, this is not ours. This is somewhere else. But it's a well-known Emmy Award winning TV drama, but collected from all the information from the viewers, individually from big data analysis. And this is a big TV show picture. And then I'm very happy that the TV show in this country is pushing very hard, and with a campaign that connect your TV to the internet. Okay, so I thought that broadcasters were that side of the internet, but I'm very glad that the broadcasting industry is pushing to connect their TV to the internet very hard like this. Okay, so the reason is that the TV turned out to be a browser-based. And look at this. This is one of the characteristics of this country. The advertisement revenue going high on the internet, going down on the other media. That's happening everywhere. But look at this. TV is increasing the revenue of the advertisement as well. So if you see the Japanese TV, let's do that tonight. And the TV commercials are from Google. So the internet companies buy a lot of TV commercial in this country. So this is not happening everywhere in the world. But the TV is, so if you create the new applications and services on top of the internet, the best way is do the TV commercial. And everybody start to use it. So that's a strange behavior. But anyway, so now this distance and the other things, I'm accepting all the situations. So we should utilize this situation. So the TV, retransmission of the TV things, and then Dave requested the very hard equivalency on a TV broadcasting when we are doing the retransmission over the internet for the TV broadcasting thing, real time. And so amazingly, the requirement was very hard, but amazingly, the entity actually created this one. And the IPv6 only multicast things for actually 4 million subscribers now. So this is the largest scale installation of the IP multicast. So if you doing the zapping thing, then it's a join and leave things on the IP multicasting. So the impact of the TV connected at home, when the quality of the TV resolution and everything going higher, then the people want the higher speed of the internet at home. So this was announced in June. 10 Gbps, a little bit less than 100 USD, so which is not very bad. I didn't test it, so don't trust me. Trust this company. But anyway, so it's a high-speed FTTH, fiber to the home thing happening because of the TV. That's a fact, and then I would like to accept that. And then this is a agriculture area. They turned out to be sensors and then nicely connected to the robot. Agriculture is robot now. They can immediately getting the almost a taste of the rice from the field, and as soon as they work. So the point is the internet and things. But let me finally doing the announcement from a wide project today about one part of the NREN thing. So this was 2 weeks ago, probably announced from Indiana University that the first 100 gig trans-Pacific circuit from Seattle to Tokyo. This is basically managed by a wide project. So we've been negotiating with the National Science Foundation for a long time. So then we couldn't making the announcement yet. So CNIC did the announcement as well. So we worked with across the Pacific, and we used to be calling our Lambda Exchange, Open Exchange in Tokyo Lambda Exchange, but because it's not the Lambda fabric anymore, so we call it the Tokyo Research Exchange, so T-Rex. That's an announcement. And the T-Rex is going to be operated by White, and then the Pacific Wave and Hawaii, and working with the National Astronomy Observatory Research Institute to start in operation in this month. So this is an announcement, but the point is, the WIDE project has been working on Asia infrastructure for the national research universities for a long time. So let me share one thing, that the NREN in Asia is in problem very much these days. Okay, the National Research and Educational Network is basically what we've been working with them, and they became a leader of the network in the network policy, network operation in each of the countries. So that's good, but the point is that when the commercial network is available, then all of the government tend to stop funding university for the network. Okay, so that's happening, and then that's only the very advanced country, rich country, they don't stop. They can manage sometimes by themselves, but then the result is the result is that Indonesia cut the budget for the National Research Educational Network. So they started to work by themselves. But Cambodia having a problem that having its own AES to operate the multiple route out from their country. So we have decided that providing the full route, available routers, switchbacks, and then also the address space as well. So it's getting worse day by day. So the point is that if the commercial network exists in a nation, then the government starts to think that we don't support the university anymore. We don't have to support the university anymore. But the reality is the high-speed network and the advanced network and in various NREM, operators education, AES operation, global internet aspect, because in the academic area, we don't have a national boundary, right? It's a single internet concept. And the acceptable use policy not to interfere, not to be bad to the commercial internet extension. This is well discussed. Advanced technology, of course, experiments, experiences, mistakes. That's really important for the engineers, technology. And then, engagement that the internet is mine. I'm going to operate. I'm going to be responsible on the future of the internet. That's really important thing. And also the science application. So please rethink joining us to support the NREM in a very places. I talked with ISOC. I talked with IETF, IETF. I'm going to talk with policy people to do that. Anyway, so time is up. Thank you very much for listening.
So we do have to be out of this room in a couple of minutes, but I wonder if you have time for one or two questions, but I expect that people may have to go. Nobody has any question. This is all like totally transparent and you're all done. Okay, well in that case, I want to thank you so much for speaking to us today. Thank you so much.